Good afternoon. Uh, as you know, this is a lunchtime. I would like to give a grace time of 5 minutes. We'll start after 5 minutes. Please bear with us.
Good afternoon, ladies and gentlemen. May I have your kind attention? The first B2B session will be starting at B2B area in Hall 1 at 2:30 p.m. All overseas buyers whose meeting are scheduled for today must reach the B2B area by 2:15 p.m. All exhibitors are invited to attend the business session today. Thank you. Good afternoon, ladies and gentlemen. May I have your kind attention, please? We have some interesting sessions covering a huge spectrum of topics. Please visit these seminars starting from 2 p.m. In Tata Steel Conference Hall, we will have a session on enhancing steel and engineering exports from India. Make in India for the world. In Technology Conference Hall, there is a session on automation and industry 4.0 for MSMEs. And in Miriam Conference Hall, we will have a session on trade and investment in G20 countries, challenges and opportunities. I request you all to visit these seminars. Thank you.
Good afternoon. delegates, it has been great pleasure for EPC, on behalf of EPC, let me welcome you. This might be the first time we are organizing this type of exclusive technology
Good afternoon, ladies
briefing.
and gentlemen. May I have your kind attention, please? The first B2B session will be starting at B2B meeting area in Hall 1 at 2:30 p.m. All overseas buyers whose meeting are scheduled for today must reach the B2B area by 2:15 p.m. All exhibitors to attend the business sessions today.
Right.
Thank you.
Next 3 days we will be having a technology session. Today's session is very apt for the theme for which we have come to Chennai. That is technology and innovation. So today's topic is very apt. It's automation in industry. So automation without innovation, without automation, industry cannot flourish. That's the end thing now. We have got a very interesting bunch of very intelligent and very experienced speakers for this session. And this total session will be moderated by none other than our immediate past chairman, APC All India chairman, Mr. Mahesh Desai, who is a very experienced person, not only in the field of manufacturing, but also in the field of exports. And he is going to also give you a brief account of EPC's activities to start with. May I please welcome Mr. Desai on the stage, please.
Good afternoon. After lunch, it's a most difficult session for everyone. If a speaker speaks little loudly, that will be disturbing the somber siesta of our. So I am going to disturb you from your somber siesta. I am Mahesh Desai. I am a technocrat, first generation entrepreneur, and my first and last love is technology. So don't misunderstand me. I have only one love, and that is technology. So my wife is a very helpful supporter to me in this adventure. Yes. Dr. Ramesh Babu, I know him, Professor, Balraman Institute, IIT, Madras. Dr. Amitesh Kumar, Professor, Department of Foundry and Forge Technology, NIAMT. Dr. Prakash Vinod, Scientist F, Head, Center of Precision Machines and Smart Manufacturing, CMTI. Mr. Gokul Deshpande, Founder, CMOS Processors. I don't know what does CMOS stand for, but I think we'll hope Dr. Gokul Deshpande to full form of CMOS. Madam Vinita Shah, Head Global Strategy, Alliance 360 TF. I've heard about 360 degrees. But what is TF total? Oh, trade finance. Okay. Mr. Muthu Kumar, Siemens Limited. my dear friend Arun Shukla, Deputy Regional Chairman, Northern Region, EPC, friends, ladies and gentlemen, welcome to this session. Very interesting topic. We are talking about one hand automation. Automation means don't touch me, no hand is touched. That's what I understand. And we talk about 4.0. 4.0 means the fourth generation revolution. Am I right? Yeah? You should correct me. Fourth generation revolution. Now what is this fourth generation? And where does automation fits into the fourth generation? And the most interesting part of the talk is the MSME. What is a small scale fellow has to do in such big things? Automation, very big word, very heavy word, and we are talking of fourth generation. So something I have heard about 21st century generation, they call it. She will be able to tell us what's that 21st generation, 21st century generation known as X something. 10? Changing, yes. So that we are learning. So here also we will learn about it. Now, how does a small scale people, man, tries to learn and adopt and then practice automation? Now automation is a very large cinemascope screen. Now small scale is one lathe machine, one drilling machine, engineering side, or one process or one step activity. Now how does it make it automatic? Now automation means any incremental improvement in the present situation or present process will be towards the automation. We should start from that rather than you have a CNC, you have digital control. No, I believe, being myself in the industry from 1967, so I know what is automation means, doesn't mean. And then in this, where does the digitalization fits in? Where does digitalization, automation and all this fits in? So we have number of speakers like our professor here, and they are here and they will be able to explain some part of it. Let me begin by, technological intervention. Let me begin by welcoming our esteemed panelist, respected guest, fellow exporters, and my fellow friends gracing this session on automation and industry 4.0. This session is exclusively for MSME. EPC India, am I heard? It's okay? So I don't. This session is being held by the support of Ministry of Heavy Industries, Government of India, Industry 4.0 or the fourth industrial revolution can be summarized as the introduction of okay? Hello? It's okay? The development of highly adaptable and modular manufacturing and logistic systems, the integration of substantial and advanced manufacturing technologies as well as promotion of automation technology and human-machine interaction. Many specialists believe that Industry 4.0 is important for enhancing quality, speed, and flexibility. These are some of the crucial components of any critical business, especially the MSME, that constitute a significant share in many industries across the globe, including the Indian engineering scenario. The recent disruptions in the global economy, including the COVID-19 pandemic, the geopolitical crisis, and the ensuing energy and food inflations have indicated the importance of automation to a greater extent. Hence, this session assumes great importance for the Indian engineering industry. While Industry 4.0 is important for the MSMEs, the adoption remains a challenge, as the new disruptions have led to speedy shift towards Industry 4.0 across the globe. It is essential for the Indian MSMEs to implement the same to ensure a much more inclusive growth. However, MSMEs in India have to confront a large number of factors, including lack of awareness, lack of financial and technological capabilities while adopting Industry 4.0. However, experts believe if MSMEs are not able to adopt this, they may miss the global automation journey, which will in turn increase the global economic inequality. Therefore, they need proper support of the industry and academia to build an ecosystem that will make the adoption process much smoother. It is also important to note here that only with proper implementation of automation and Industry 4.0 can India achieve success in promoting Brand India, Make in India across the globe. Given this background, I thank Ministry of Heavy Industry and EPC India for organizing this session, which brings together stakeholders from different sectors, including the government and academia, and envisages finding the way to enable the main and Indian MSME successfully to understand and adopt and implement fourth industrial revolution. Now something from my experience. I have traveled from one lathe and one drilling machine, ordinary, made in Punjab. You can say manual. And I have traveled a very long journey. The best thing for MSME sector, see, first of all, we all talk about MSME. Very micro, medium, small, and all that. Now the adoption level at micro level of different sector of industry is different. At the small scale sector and also medium. So medium people are having finances, manpower, and also their adoption capability is much greater than the small scale. Now the small scale, when it goes for automation, there are disruptions of many things, because he has been working for that process, that thing. Most of these are family-owned companies. So adoption, first of all, there is a resistance, there is an inertia, something new. These people feel, oh, I have been doing from 20 years, why should I change? There's no need for me to change. I am perfect in my thing. So he's very cozy, he's very comfortable in his domain. Now, how does he come out of it? How does he feel? Unless until there is a disruption. But adoption also creates further disruptions. Psychological, financial, and then many people get They lost. Nahi, karna hai. I don't want to do it. I am very good in my old methodology. I'll go back that. But when he finds that his products are not competitive, his products are not being now recognized or accepted because of change in so many process and even price wise, he becomes costly, unacceptable in the marketplace. Then he sees his neighbor adopting some changes, then he goes for this. Because I deal with so many micro clusters, and that's why we begin. Earlier, and then adoption or disruptions at a stage. See, I can't take them to take to HMT with the automatic process and everything. But I can take to a third level of the HMT supplier who has adopted little bit of automation and who has been now same thing. To adopt adoption and changes, we need finance. Now finance at affordable cost. Madam is here. Small people are charged maximum because he suffers everywhere, from finance, from everywhere, because no bank will come forward to give him large amount. So they go to the second level or third level, or the private lender. Even for adoption, this is a cost, and this cost will also increase his cost of product to the market. So he may be thrown out before he gets into the market with changes. So these are the few things where you people are here. Please deliberate on that and give us some small, simple tablets. Don't give us a full prescription of 1 page long like super specialist. So that by the time I read and I understand, I am lost. Thank you. Some food for thought to so specialist here. Thank you for listening.
Ajay, let me request Dr. Ramesh Babu to ignite the session with his very interesting deliberation.
So, good afternoon to all the delegates who are present here at this session. I used to attend the CEPC trade shows and engineering sourcing shows also. First, let me thank the organizers for inviting me to this particular session. And of course, I have lots of things to say, but then let me limit it to certain things which, our the earlier speaker, Mr. Desai, has triggered. I am a professor at IIT teaching automation for all the students right from the BTech to the MTech and PhDs. I know how the automation has advanced over the last 5 to 6 decades. I think what you mentioned about the automation in MSME and today's automation in mega companies and major industries is different. That's where the automation is viewed by the MSMEs in a particular way, but they need to be geared up to the Industry 4.0, which is the fourth generation automation. I think that's where the challenge is. I think he has also elaborated many things like mindset, and then limited finances, and then comfortable living in the companies are the ones which are making them to continue to do what they are doing it, but then they get lost in course of time and they are not gearing up to the next level of automation. I think this is where I wanted to share my experiences over the last maybe 15 to 20 years at IIT by interacting with many industries, not only Indian industries but also multinationals. I think my experience at IIT has always been the translational research center. In the sense, I never used to stop with only the prototyping from the ideation. That's where most of the researchers will stop. But then because I worked in ISRO, I was also in a multinational company, then I came to IIT. That gave me the direction that I need to work towards the translation so that it will be useful for any industry. Can be a small industry, a large scale industry, etc. I think what I did over the last 3.5 decades of my stay at IIT was collaborate and then develop something which is useful to the industry. I think first I started with a multinational company in Japan, which is Amada Sheet Metal Manufacturers. I was consultant, I am still the consultant for them. That's where I learned how the Japanese used to think of precision in product development. In the sense, they never used to stop at any level. But then parallelly, I used to work with many MSMEs in India also, who used to come to IIT Madras for solving their problems. But then for them, they want solution yesterday. They'll come to me today and then say, can you give me the solution tomorrow morning, which is not possible. But whereas the multinationals will never look at it in that way. They try to invest the money and then see that they can get the output even after 6 months or 1 year. I think the speed at which we need to deliver it to the MSMEs is the challenge in any academic institutions, whether it be IIT or NIT or engineering college, etc. How do we do that? One is the government also is promoting today. An industry comes and says that I have a very limited resources. I think that's where the industry being supported by the government in order to enhance their R&D capabilities. I think that has started with the MHI launching a scheme in 2014 November, and we were the first to get the Center of Excellence. And then we have been very successful in attracting a few MSMEs, and some of them are from here, from Maharashtra, and major industries from Gujarat and others. I think I don't know how much time I have got it, but then if you allow me that I can present it, otherwise I can also share what we have done it for towards automation and also Industry 4.0. I think it is a collaboration of many industries and partners, which we call it as a special interest group, to come together and then share their experiences first, share their expertise next, then experience what is meant by this Industry 4.0 is the third one. So by means of this one, the academia can enable the MSMEs to understand what is meant by the transition from the automation to Industry 4.0. I think that's what we are doing it at IIT Madras, and of course many other IITs are also doing in some way or the other to give the experiences to the MSME. I think this is where I may quickly run through some of them so that you will get an idea. Otherwise, I'll keep talking about it, but you don't get the message, straight and loud. Can I just go to? Yeah, I'll just use this one. So I think this is where the MHI's initiatives have enabled the various institutions and various industries to come together. And this funding was phase 1 funding of about 550 crores. I think those who are from the industry they may be aware. I think EEPC knows it very well. So we got only 56 crores with 6 industry partners carrying out 11 technology development projects. We didn't do something and then left it, but we have delivered those things. I'm going to show those pictures in the next few slides. And what I am covering it here is our involvement at this center, which is set up as a not-for-profit society in IITM Research Park, is one of the first centers. And of course, later on, a few more centers have come up in other IITs and other places also. So we got involved in almost different components, all the components of the scheme, wherein first they said the technology development, they said skill development. Then next they said, how do you bring the people together to cooperate and collaborate and do contract manufacturing? And that's where you can see these platforms and other efforts of IIT Madras. I think this is again, as I said, that there are 6 industries. You can see the ACE group is one, Jyoti from Rajkot, and MSMEs from Chennai, from Ambattur Industrial Estate, and also from Perungudi, then from Thane. So all of them have approached through the IMTMA. See, here the collaboration and cooperation is essential because I can't do myself alone. So IMTMA has enabled them to showcase our capabilities, which we have done it earlier through several projects to the industry. And then they came to us, yes, we are willing to put in 20% and take 80% for doing R&D. And all these projects are 20% by the industry. Unless the 20 rupees is given by the industry, government will not release 80%. I think we have successfully completed all the projects and we are getting into the next phase, wherein again we have got 4 more industries contributing 20% and 80% from the government. I think this is the story that I wanted to narrate it to begin with, that how the industry, academia and government collaborate together to make the MSMEs to develop those technologies which can go into the market and which can make a transition from the automation to the industry 4.0. I think with this setting, I'll quickly run through a few slides because that will give a feel of what we have done it. Next. I think this was inaugurated by the then Secretary Dr. Sehag and also Madam Sukriti Likhi and almost all the industries, IMTMA presidents and members, and all of them have come, and it was inaugurated in 2019 August. Of course, after we completed the projects, we got them in 2016, and in 3 years we have worked together with so many members from both the sides working and then delivering this one. And before that, when we received the money, the government said that you make it as a special purpose vehicle. And then we made this one in the research park in a space of about 10,000 square feet. And we call this as a translational research center for enhancing the skills of youth as well as the engineers from the industry, and also incubate and bring some startups. There are several startups which we have started, and some of our own students and others also have worked on this one. So the areas in which we have been working with all these industries and all the manufacturing related activities, core technologies, then digital manufacturing, industrial automation and robotics, and also smart manufacturing. I think I will show you some of the machines and technologies developed. Here, when we talk about the machine, I don't develop the entire machine. I only look at some component which needs a high precision or high efficiency or anything. If you look at these machines, they are being sold by these companies, but then they don't know how to improve their efficiency, how to improve the precision levels. And that's where the Chennai Medco and other companies have come to us. So these are the burning problems which we want to solve it. And we don't want to take this one in a reverse mode, but in a forward mode. Define the requirements, go through the fundamentals, basics, and then develop the prototype. Then ask them to test it. Then again revise the designs and drawings and then send them. That is how the entire process has happened at our center, with engineers being recruited. They're all talented, either from the industry or from the academia with PhDs and MS and other things. I think this is where you can see it in our center. You are all welcome to IITM Research Park at any time to see these things. And still we are doing many more which you can experience it. Then there are certain technologies which are denied, which the industry wants to develop them in India. And these are some of them we have patented. About 5 patents are filed, and one of them is international patent for the hydrostatic guideways, hydrostatic spindles, hydrostatic bearings, which these technologies nobody would like to give it to you and then share those technologies. And of course we also did several things for the defense in order to build the entire prototype for dismantling the ammunition which is time expired, and we delivered it to them also. I think these are in terms of the core technologies. Similarly, we went into the digital and smart manufacturing. There are two fronts on which we should focus on. One is when you say the smart, smart is everywhere. Smart machine tools, smart manufacturing system, smart machining system, smart processes. That's where you can see that our efforts, in all these 11 technology development projects is towards that, to bring some sort of a framework from the academic institutions and offer them. So since we have several contacts, not only from Indian academia, but all over the world, and they have been very positive and collaborative in order to bring these cooperation networks. So even they also benefit from the knowledge that we uh, just gather and then give it to them. So this is where the process intelligence is captured, and we made the software for that one. And now we have a tie-up with Canadian company, again the Indian NRI. So we wanted to take it to the North, the Americas, in the sense, North America as well as the Canada, so that the people will realize the importance of such, methods in a small and medium scale enterprises. See, we don't want to give it to mega companies. All we wanted to focus on the MSMEs. And the other one is the machine tools giving some precision in terms of a 5 microns requires an imported machine. But Indian machine tools will get about 35 to 50 microns is the precision when you operate these machines morning to evening. And with ACE designers, we collaborated and then brought this machine and end to end, in the sense right from monitoring to the controlling, so that the precision levels are in the nature of, in the order of 5 to 8 microns. I think this is how we generate. And automation, we started with a robo development with the 2 payloads. Now we are accelerating it from 4 kgs to 200 kgs under the phase 2. The money was given and the industries were partnering with that to make all the aggregates, and somebody else will do the integration along with the process. I think they are all from Bangalore, Prerana Engineering Works, and then M2 Next, which is subsidiary of Bharat Fridge. So I am saying all these things. There are some small and medium enterprises which are included in all of them. It is not that they will do everything. So the drives for the machine tools. Then with all this know-how and experience, we also helped many government agencies like ARCI. When they developed the fuel cell technology, if they give it to somebody, either they may take it and then own that one, or claim if you just completely transfer it. So they said that you do it so that you are an academic institution, you don't have any interest in commercialization. So hence we build the entire assembly line automation using the handling systems and various units. That's where you can see the entire thing. I'm not going to play the videos for the reason that the time is very limited. So then the secretary and the others requested us to develop the technology platform to connect the people. This is again some sort of innovative content which is behind the platform. In the sense, knowledge graphs, that we use it in most of the Google, Amazon, LinkedIn, etc. So we are using such knowledge graphs behind that one, so that the expandability and usability and reach, to various extents is also possible. And in this again, we focused on the skill development and internships through various, programs. I think this is, I think we have offered it to many colleges, about 300 to 350 at each institution. CMTI also was engaged in that one, RI, ICAT. So the secretary said that you have to collaborate with all of them and then bring about 1500 during COVID. I'll give the money and we will do that one. So all these initiatives are by the government, and the government is proactive in the current scenario, and they are asking the academia to put more effort in order to bring out this connectivity between the students to the experienced people. That's where we did that. And of course there are problems which are faced by the society, like either fruit harvesting or a cotton crop harvesting or a mobile like a truck or something which can be used by the street vendors and all of them. So we did all of them with the solar energy. I think you can visit and get to know about the outcome of the internships which have taken place over the period of time. And I think and we have brought a lot of industries and also the MSMEs to be part of this entire ecosystem, so that they can be fed with the young students who can solve their problems. And that's where you can see the skill development efforts are going on. And apart from all of them, with our contacts all over the world, We also organize webinars for the benefit of all the mentors and mentees also. And some of them are shown here. And we use specialized programs on the mechatronics, which is again automation. But then with this, we have built an ecosystem wherein we have more than maybe 400 to 500 people in this country, always, connected in some way or the other with the experts to the industries and others. And very recently, in last year, with all these activities, we felt that smart manufacturing is the key today. That's where we talk about Industry 4.0. And four organizations have come together. One is the Cantier from Philippines and Singapore. They are supplying the MES system. And then Mesa International is in USA and Europe. APAC is another one in the Asia Pacific region. So we have come together and then formed a virtual center with the objective of identifying the automation levels in MSME through the assessment, maturity assessment. Next one is we also educate them and give them an experience of what is smart manufacturing through our center, where we have the machines, we have the processes which are made into smart, and we are also collecting the data from the controllers and then demonstrating it. So I think this was inaugurated only a few months ago. Our mandate is fivefold, as you can see. One is how do we assess the maturity of a MSME? And then how do we really educate them to move from their level to the next level? And what type of experience we can provide to bring in different technologies such as the computers, information technologies, security, sensors, actuators, data analytics and protocols. And again, we are not doing ourselves, we are doing it with a special interest group wherein anybody can become part of this group so that they can offer their solutions and test them on this test bed. But please remember that we are not competitors, we are not commercial organization, we are only educating them and giving them experience. Then we can solve their problems and then build a supply chain, etc., which will be helpful to that. I think this is where some efforts in this direction are going on. I just thought that I will share them. I think I can keep talking about it. I didn't want to showcase the other projects which we do it for our own students, faculty members who come up with some innovative ideas, and we make them into products and then make them to experience it so that the industry can come and then take their technologies. I think there are several collaborative efforts which I didn't want to go through. So if you want to know, I can leave this presentation, you can share it with anybody. So this is the place where our entire center is located. I didn't want to have this center within the IIT, then it becomes another center like any other center. So it is completely managed independently in the research park in a space of about 9,000 to 10,000 square feet, with everything being made by a set of engineers, and many students keep coming and then experiencing every bit of what I said in my presentation. So thank you very much. I think this is where I thought that, how do you connect between the automation and Industry 4.0? See, this is how the MSMEs can be encouraged to interact with many institutions, academia, and then showcase their problems and then experience themselves. Thank you.
Thank you, Dr. Ramesh Babu. It's a pleasure for us to know how IIT Madras has really reached out their technical hand to the industry, to the students, and develop a beautiful connection, beautiful connect, the networking of sharing of information and technology, whatever development. So this has been very important and very lovely experience for us. We will keep the presentation with us and we will share among all interested participants here in the show. I will request Dr. Amitesh Kumar of National Institute of Advanced Manufacturing Technology, erstwhile known as NIFT, that is National Institute of Foundry of Forge. This is located in Ranchi, and they have done remarkable work in the region of MSMEs in Jharkhand area. I request Dr. Kumar to enlighten. I just request all speakers to restrict their deliberation within 12 to 15 minutes to give a chance for others, and maybe interactions can happen after that. Thank you, please.
Uh, uh, Dear speakers and the delegates, I am from the NIMT Ranchi. Formerly it was NIFFT Ranchi, National Institute of Foundry and Forge Technology. So my area is the foundry technology. So in that area, we are just relating with the foundry industries, whatever eastern region and the throughout the India. The maximum thing what we are doing the training program for the development of the new component and also the upgradation of the knowledge. So that is the automation is the part of that for any development of any component, all sort of things. We have some like using the simulation software, writing the code, so that before going to the shop floor practice, we are developing what we are showing, what are the problems, in what we have to do, the related to design of the component, the designing of the gating system, or what we can say the methoding. So we are developing the small clusters like the in the Jharkhand region. So somewhere forging cluster, in the foundry clusters, and also we are doing for like the surgical instrument, the manufacturer in the Baripur, Calcutta. So they have to use to make small units. So we have to make the one cluster so that they can use the manufacturing system, so that they compete the outside the country. So they are very expert in their field, but they do not have the updated machines. But they have selected like the what can say the metal injection molding, so they can get the near-net type kinds of the shapes and including the hot forgings. So our aims to give supply, what can say the make the DPR, again the give the training so that can develop. So whatever the manufacturer, they can come to the cluster, use that facility, common facility, and they can go for the production. So whatever in the talk in my nothing there, only what I will talk. So that is the basic about the automation in the foundry. So little bit just I will talk about the automation in the foundry, and maximum thing what is automation, all sort of things, all are experts. So no need to go through that. Automation in the foundry means whatever the processes, all the steps. So each and every parameters we have to check, because in the foundry you will see the n number of parameters. So anything will happen, you will get the defective casting. So start from the basic raw materials, making the mold like the sand. So we have to control the sand system. So how it is going to process mixing or the mulling kinds of the things. From that again we have to go the second thing, making the mold and the core. So these things we can go for the automation based on the whatever the machines, equipments are there, that can be automized on the data, whatever the things are there, we can use the help of the smart manufacturing or industry 4.0. And after this molding, then there will be melting sections, so control of the alloying, the temperature, parameters, and there should be the liquid metal should be pure, so that there should not be any contamination into that, and then designing of the gating system. So number of softwares are available, they are doing fantastic job. You do not have to go to the shop floor, you can do simulation works and design the gating system and the rising for the different materials. So only thing is liking that the what is thermophysical properties, because the different alloy in the different condition it's going to change. So that data input is necessary. But if you go for the foundry like the gray iron, aluminum casting, you can have data, and also use that data for the simulation and see the where we are getting the problems, like the casting defects. If you understand like the porosity, pinholes, and the shrinkage, that you can either change the design. If it is not possible, change in the design of the gating system. So based on that you can modify it. And also whatever after that it is coming again the finishing parts. The finishing parts what we are going to break the mold, and the automation is coming wherever like the lot of fumes, dust. So how to we have to avoid? There should not be intervention of the main powers. That area, and even at the melting where it is at a high temperature, that is very hazardous. That type we can provide the robot so that that process can be done by robots, like the casting removal, the pouring, coating, all sort of things, and also some precision. Wherever applied, that you can use that robot, or what you can say the automation kinds of the system, so that the manpower you can reduce. So in the production of the core, again we require the precision, that because it is internal structure of the casting. So that there also robot system can be applied. And finally, if you go for the pouring, how the flow of the liquid metal that cannot predict from the outside, that can be because it is the what can inside the mold, it is not transparent. So for that we have to check the flow. That flow can be seen by the simulation. So that is going to helpful how it is going to flow, how it is going to fill the mold cavity, and after consequently how it is going to solidify. So after solidification, what defects may come, providing this arrangement. So based on the theoretical backup and the experimental data, you can verify that a simulated result, and finally you can show. So if you do that, we can get, then finally you can go for the production. So each and every steps starting from the sand making, the molding, the melting, pouring, and the finally trimming, finishing, and the final treatment to the metal. So we have to automate it so that we can get the sound casting, and also some important thing is that wherever the hazardous system, because the playing with the liquid metal is not safe. So that side, and wherever the more what can say the fumes, dew, dust, and the escapes of the gases, that we can we cannot use the huge manpower. So there we can provide the robots. So based on this, automation will play a role for the production, and you will get the good casting. So timely you can provide the casting, and with a cheaper cost compared to that, and the product wise you can customize whatever the not it is what can say the production. So you can go for the any customization of design or changes that you can make by the smart manufacturing. Okay, thank you.
So, so this was very exclusive automation in the foundry section, because casting, Eastern region has been predominantly a casting and forging industry dominated area. Okay, and they have done a remarkable job in automation of the foundry, smart furnace, and all. They're going towards the making of a smart furnace, I believe, smart furnace, and that will help us because the base metal of all the product, in maximum product, is the metal. So there's a lot of development which has been coming in, and they have been doing a lot of development work in their center. Uh, I will now request Mr. Prakash Binod of Central Manufacturing Technology Institute. He is looking after smart manufacturing, precision machine tools, and aggregates. Thank you, sir.
So I'd like to thank first the organizers to give, for giving us opportunity, giving CMTI opportunity to talk on the subject. Myself Prakash Vinod, and presently I am heading a vertical of CMTI which works on smart manufacturing industry 4.0. I am lucky to have previous speakers who has already covered some of the things, and I try to go faster a little bit because of that. So, few words about our CMTI. CMTI, we come under Ministry of Heavy Industry. We are autonomous organization. We do technology development work for various advanced manufacturing technologies. We started with machine tools in 1962, and then we have gone into various advanced manufacturing technology, including nano manufacturing, mechatronics, automations, sensor development, textile machinery development, and many core technologies which are mother technologies for building machines and machine tools. Presently, smart manufacturing industry 4.0 is one of the focus of our Ministry of Heavy Industry, and of course, it is also of CMTI. So, coming to that, I think as sir already told, we came to industry 4.0, right? Fourth industrial revolution. But we should not forget that we have majority of machines in our country with MSME, which is of generation industry 2.0 and 3.0, which as he mentioned, has gone through incremental automations and all. Suddenly, industry 4.0 came, how actually automation is always there. From last 50 years, we have been doing automation. Industry 4.0 is trying to connect your all asset, all machines, all your, before machine, you have to do design optimization, you have to do computer-aided manufacturing optimization, then manufacturing comes, and then quality assurance comes. So it is connecting, and then supply chain. So this smart manufacturing is providing you a platform sort of thing where we can connect all, and we should look into improvement of each of the subsystem of complete manufacturing ecosystem. That is the way it works. So basically this thing is given by IIoT. That is the basic thing on which industry 4.0 there. And then people look into entire manufacturing system as a cyber physical system. We have physical things and you have digital form of that also available. If you have all those things, then you can do a lot of analytics which are based on machine learning, artificial intelligence, and for that, if you do such things, you can predict your quality, you can predict the failures which are going to occur, and you can take corrective action, autonomous. So that is the way this smart manufacturing is there. It is not only machines, and it is complete ecosystem which is going behind manufacturing. We need to connect, and we have to see, we have to apply everywhere the tools, IT tools and all, which can improve quality, productivity, efficiencies. That is the way we look into smart manufacturing. So that's the way I mentioned that if we are trying to connect MSMEs, we have to tell them how it is useful to them. So definitely they adopt industry 4.0 smart manufacturing, the product quality is going to improve. I think there is no zero defect. In fact, you can predict the quality also if you have the smart manufacturing systems. We can reduce the cost in various ways. I will not go through that. So it will help you to reduce cost. Product cost will come down. Productivity will increase, and the entire efficiency of the manufacturing system will improve. Now coming to that MSME, I think you all, most of them from MSME, so I need not to tell you what is the importance of MSME in our Indian manufacturing system. It is giving, in fact, largest employment, plus also it plays a bigger role in manufacturing output and all that we all know. Let us see what challenges this MSME is facing, and then that's why we have to come out with innovative solutions which works for most of them. So as I mentioned that they have a lot of machineries which are industry 2.0, 3.0 based systems. So we need to see that properly digitize, and there is upgradation to some extent without adding much cost into their production systems, right? And they have a large volume of legacy machine. In fact, if you see most of the MSME, their machines are not ready, fully ready to be quickly connected with your industry 4.0 IoT platform. So that we have to look into, and different type of machines have different type of issues, connectivity issues and all. So that also we have to address. And We have to tell them what if you invest something, what is the return on investment, and that is there. And also we should see that different MSMEs are working in different sectors. As just now he mentioned, some people work on foundry, and foundry also he just mentioned about sand foundry. There is another sector working on investment casting. So we have to come out with some solutions which works for most of them. Then only it becomes more useful. That is the way we have to look into that. And there is always data security issues and all, because they have something, they feel that they own something, and if you connect the thing and make it open, somebody can, whatever the knowledge they can take away from them. And also they are afraid because they are not, if somebody comes to them, they are not sure what to take and what not to take, because there is no standardization as such, so standardization is also important. And for that doing all, we need to do a lot of indigenous development of IoT products and all, which works for most of the MSME. And we need to have a lot of test lab, test platforms where it can be tested. So CMTI as such is one of the Samarth Udyog Center, as Professor Ramesh Babu mentioned, that MHI had taken initiative to put up Industry 4.0 center all over India. So at CMTI, there is one center where we are working on development of various indigenous technologies which are suitable for MSME of different sectors. That is the way we have worked. I will just quickly show you a few of them. Then also we have a smart factory. We have built a smart factory which has got all combination of machines, Industry 2.0, legacy machines, legacy CNC machines, modern CNC machines, sort of all. And there we have tried to connect the entire manufacturing ecosystem, starting from design to design optimization to manufacturing optimization, then CAM, then actual manufacturing, online inspection on machines, then post manufacturing inspection and quality control and all. So we have tried to demonstrate each and everything in that. And we have also come out with many solutions which we already implemented in MSME of different sectors. So this is the way our center is working, which is working on smart manufacturing. We have a lot of IoT or Industry 4.0 implementation which people can adopt, MSME can adopt. We are coming out a lot of development work with our own internal R&D. Also, we are working with industry collaboration project, which is part of MHI scheme also, where we are working with other industry partners. They are also collaborating with us. Some of them, they are MSME, some of them, they are MNC. But we have seen that whatever product comes out, it is useful for Indian industry, and they can take and export also. That is the way we look into that. So we also conduct a lot of training program. Skill development is one of the major activity which our center is doing. I have a complete presentation for our smart factory, but I will not show because of lack of time. And then just you can have a look on that. In this screen, it is visible. We have sort of like a complete, you can see from right top, there's a design sort of, studio, which is smart design sort of thing. We can do optimization and all. And once everything is done, then you can create, programs and all, which can be fed to the machine. Any of the machine as per the requirement of the job, and then machining can happen. And the meantime, the raw material and all, it comes through, and it gets identified, and then it goes to different machines, and process by process, it gets completed. Then it goes for inspection. The inspection could be on machine or outside machine. Some of the inspection you need to do outside machine also because of some technology issues. Then after that, that's called smart metrology. If everything is okay, then the product which is good, it comes out of that. Apart from that, as we understand, to take care of automation and Industry 4.0 related technology, we have set up many hands-on labs, experimental learning labs for skilling and reskilling both. Means we are there, students, budding engineers we are training, plus also industry executives at different levels also, we are trying to train them on various technologies which are driving automation as well as Industry 4.0. You can see some of them like robot and cobot, mechatronics, industrial automation laboratory, control system laboratory, AR, VR laboratory, and hydraulics, pneumatics laboratory, condition monitoring laboratory. These are where people can hands-on this thing. learning, and we are conducting a lot of programs. So in a nutshell, in last 4 years, we have developed almost 12 indigenous technology ready for technology transfer. And with industry partners, another 6 technology we have developed, which are also ready for basically it goes to industry partner first, and after 3 years, it is becomes open for all the other industries also. And I told you about experimental learning lab, and you can see maybe around 10,000 plus we have done skilling and reskilling in the last 4 years. Coming to our solutions we have put in cmti.iot.online, which we developed at in CMTI. They are all low cost, affordable for MSME. If you see, I will not go because of lack of time. They are basically for different purpose: energy monitoring, process monitoring, productivity monitoring, machine monitoring, all they are there. The modular solutions which can be based on the requirement, we can use it for respective use. Some of the work I will just quickly take you to some of the few works which CMTI has done. We have developed many smart machine or manufacturing system. One of this is the metal cutting machine tool, which is an ultra precision machine tool itself. It is one of the accuracy wise is one of the best machine tool in the world. Apart from that, if you see, this machine is loaded with all sort of industry 4.0 technologies, where machine error can be compensated, automatically in the background by adaptive control techniques. It could be, as professor was mentioning about thermoelastic errors and all. Apart from that, we have other errors also, like geometrical, volumetric errors and all, positioning and all. That all can be mapped in real time, and it can be compensated. Apart from that, we have for machine diagnostics, we have cutting tool in machine tools, so that can be tool condition monitoring can be done. Machine health can be monitored, and we can predict the lives also. That is the way we have done in that. Even the process, I think, because of lack of time, I think, because I know how IIT Madras works. So in grinding like that, they have done. They can predict the outcome of the process. Likewise, for turning, CMT also has done. We can predict as the machining process goes on. We can predict this thing. I will not go through that, how to develop a small module which is useful for MSMEs and all for taking care of thermoelastic error. I think already professor has covered. So some similar work was done by CMTI, and this has been implemented in our machine. And we can see we can even control a tolerance of 1 micrometer on job if you adopt this thermal error compensation and all. So that way we can do. Even if you can see that surface as the process in turning process take place, the surface which can come out of that roughness of that this thing job can be predicted as the machining take place using again AI/ML based techniques and all. It is all demonstrated. We have developed many technologies to convert legacy machines. Legacy means it could be a sort of automated manually operated machines also, or it could be legacy CNC machines which you have for last 25 years and it is working fine. So for that also we developed many technologies which can be added to that, and it can work in industry 4.0 environment. That is the way CMT has done. This is the example. I think I will be answering to Professor Amitesh. I think they are aware of our activity regarding this. For smart foundry, just now he mentioned that that foundry consists of 3D printing, sand mixing, mold making, and also metal casting. So these are these machines. If you see as on date, they are like a solo machines actually. There could be some automation, or some places it's not automation much also. We have taken a challenge there. We have taken all these solo machines, which is our industry 2.0, and then we have created you can see the center. If you see, we have created a common sort of a control system where all these things are going there, and then we created a dashboard where we can monitor and control all the machines. So we converted the entire this solo, industry 2.3.0 like a modern industry 4.0 sort of system where we can monitor and control the entire sand foundry process, starting from pattern making, 3D printing, and then we developed entire machine itself. We call iFoundry. This we have displayed in the last IMTEX 2020 this year in IMTEX January. There what we have done, we have come out with a machine, single machine, where all these, like 3D printing as well as sand mixing and mold making and metal casting, all are part of one machine only. So you press one button and then everything happens through automation, and also driven by Industry 4.0 technology. As sir was telling, is that you require a lot of simulation assistance and all when you talk of metal casting. So this has provision that the simulation result which comes from metal casting design and simulation, that can be fed to the machine. And also it has lot of inbuilt edge-based analytics which are based on AI/ML vision-based thing. It will control. It will see that it is the process is under control and the quality product comes. Apart from this, entire data which is coming from different subunit of the machine can go to a cloud for further analytics, post that production analytics, and that is the way we have done. We have also worked on digital twin. I think for some people who want to, these are the advanced things which have been working. Maybe it is going to, has a lot of potential to adopt. So now when we are talking of cyber physical system, we are looking a digital model which can truly represent the physical system itself. Means, for example, instead of doing some test, on the real machine, you can, if it is a physics-based digital twin, you can carry out test directly on digital model. So a lot of things, and also you can predict life of each and every element of your mechanism or machining system by that. So for machine tool, because that is our core domain, so we have created a digital twin where we can, all the elements which are major part of machine tools like ball screw, bearings, guideways, feed motors, spindle motors and all, we created digital twin where we can check the performance and all in the, as it works, and also we can find the residual life and all. So that is the way we have done that way. And again, for SME, we have created sort of like for predictive maintenance is one of the common thing for most of the SME. So what we have done, we have created some sort of edge-based device where it can take inputs for energy, it can take inputs from vibration, and it can take inputs from temperature, and then we have some many analytics we are doing based on these inputs for predictive maintenance of machines. It can be applied to machine tool, it can be applied to any machine. So that way we have done that, it is useful for most of things. These are some of the implementation we have done already. With lack of time, will not tell you. So this we have done at Toyota one plant. 59 machine you can see in one dashboard. You can see each block, right? And each block had small units. So those are subsystem of the machines. And by just seeing that, you can find out which machine, which subsystem has some issues. Then you can further get deep into that and find out why it is, it is showing red and all. So that way we are done. This we have done for a SME which has got only eight machines at in Bangalore, Pina Industrial Estate. There we have just by using energy monitoring system, we have connected all 8 machines, and we are doing, we are finding out the productivity. How long the machine is in actual use and how much it is idle, and all sort of reasons and all we are finding out. Apart from finding out energy cost and all. So future 10 Industry 4.0, I think you all know that we are getting driven by AI/ML, data analytics, predictive data, adaptive controls, digital twins, AR, use of AR in maintenance, assembly, as well as training. It is going to increase. These are some of the things which I wanted to tell you. And now this is my last slide. How we can work, means how CMTI like a Samarth Center, can work for MSME. So we can do technology and product development. Suppose some sector, like for example, if people from foundry, investment foundry cluster, they come and tell us the problem, and then we can work with them and we can develop a solution which are useful for the entire cluster. That is the way CMTI has been doing. Many things we have done, and future also we like to do. Apart from that, some of the products which we have already developed, that can be taken, by some of the, again, startup and again MSME, which they can do the production. CMTI cannot generally don't do the production. We are also like IIT, we are non-profit organization. So we like that our technology to be taken to people, and that they can do manufacturing, taking manufacturing license from us. Apart from that, they can use our facility. We have created a test platform. If anybody has developed any product and it want to be tested at our center, we can help them. And if somebody comes for a customized solution, any industry for, or any sector, then we can provide the solutions and all. Of course, we have been doing a lot of training programs, customized training programs for various industry sectors, for various MSME, including some MSME cluster from Chennai and all. They also have approached us and we helped them to conduct many programs and all. So this is all about, in nutshell, about this thing. If you like to know more, please feel free to contact us, as well as some videos are there. Maybe I think I request organizers to share with people if they want. Yeah. Thank you.
Thank you, Vinod sir. I think he has said in a very lucid manner how the technology development has metamorphosed during the different stages from 1 to 4, Industry 4.0 and beyond. And they have done extensive research on how IoT can be utilized in controlling the total systems in a manufacturing process. And further, use of AI and ML that has been the in thing now. And they have now, again, going for augmented reality, I think. AR is augmented. That's the very latest thing. Thank you. Like he has got extensive thing, though he said that in a nutshell, but I don't know the size of the nut. If this has been the content of the nutshell. In fact, anybody who wants to have an interaction after this session, they can have interaction with him. Very knowledgeable person and all. I will now request Mr. Deshpande to come up and deliver his speech. Come. Please, sir.
Good afternoon, everybody. After listening to so many stalwarts, I am one of the small person in the automation industry. I founded the company in 1987, CMOS processors. I owe explanation to Dilip Bhai, Mahesh Bhai. The CMOS is complementary metal oxide silicon, which is a technology by which most of the components are manufactured today. Way back in 79, when I passed out of the college, I started first working on those kind of products. They were totally new. So I said, whenever I start my company will be CMOS processors. I could start only by 87, 88. I started in Chennai. Our company base is in Chennai. We are part of AIA, Automation Industry Association, which is a flagship body in the automation. Most of the, we'll go through the presentation, okay. Coming to manufacturing and industry and automation, government initiatives have been done by many countries. Like Germany has Industry 4.0, as they call it. Japan has their own initiative. US has their own initiative. India also, we have our own initiative, which is Samarth Udyog. And is most of the excellence centers, they come under Samarth Udyog. Samarth Udyog is, we can say, the Indianization of Industry 4.0. The manufacturing leadership can be brought about by transforming man, machine, and methods. And that is what Samarth Udyog talks about, and Industry 4.0 talks about same thing. Gaps seen in the MSME today are like need for making the work smarter, lack of data traceability, requirement of operator upskilling, struggles with end-of-line QA, maintenance management, and documentation, which is a generally poor part of our manufacturing industry. can we turn this around? Non-reliability, unevenness in the production, uh, overlooking a product, overlooking a mistake because of the human, what do you call, we have a myth that we have cheaper manpower and cheapest manpower in the world, and that's the reason we employ maximum manpower, but then the manpower has their own limitations. One of the reason why automation comes into picture is that something which can be repeatedly done by machine, human brain or human is not needed for that purpose. But then that is what is there. And then taking risks, dangerous things in the factory, fatigue to the operator, which is one of the reason for many of the what do you call quality issues, and low productivity. Can we turn around this? And this is a reason why Industry 4.0 or Samarth Udyog comes into the picture. We have talked about, everybody has talked about machines which are there in the industry, CMTF, Mr. Prakash Babu. Prakash has talked about second generation and third generation machines, and they being used to make means data as such. So modernize your asset with smart automation. We add vibration detectors, we add certain, you take a simple manual lathe and it can be converted to take the data which is related or required for Industry 4.0. This is not working. Industry 4.0 or fourth revolution. As we talk about the fourth revolution, data from machines, smart asset, and analyzing it. Using the analysis for better efficiency, optimum utilization of these assets. Why we are talking of Industry 4.0 now? One of the major reason is reduction in the size of memory chips. If you remember, 20 years back, the memories were too bad, in the sense, my first computer, I remember, had 640 KB RAM and a 20 MB hard disk. And that also was supposed to be one of the best machine. But today, smartphones are 8 GB RAM and 256 GB total memory as such. So then the increasing the speed of internet. When the internet came, probably, I mean, when I started using internet, it was at 2.4 kbps. Today we don't think of that. We can't think of that kind of a speed. Those days we definitely used to call that as a WWW, was expanded by people like us as World Wide Wait. You have to keep waiting for things to load. Today the speeds we talk of, even our smartphone talks of 2 Mbps, 8 Mbps, 16 Mbps. That's what speed of internet, and the decreasing cost of connectivity. The cost of connectivity, I remember yesterday only we were just talking in the office about the history of how it was happening. And I remember that first time in a greeting, this is a story about 95. In the greeting, we were using the sprint mail, and one of my IT fellow wanted to send a picture file instead of data, instead of text file. So he sent a 50K picture file to about 100 of my customers, and I received a bill of 50,000 rupees from Sprint RPG. Definitely I fought with them saying that you didn't want me, but then okay. That was a cost of communication, a cost of connectivity those days, and today it is probably few hundred rupees for few GBs, which is too low. And that's the reason Industry 4.0 or the data management can be talked about. Where we not aware that the data is going to be useful for analysis, we were aware, but it was impossible. It was not so easily possible as it is possible today. So what is the Industry 4.0? This is a fourth revolution. It is related to more efficient production processes, new marketing and business models, and stronger customer connectivity. In short, efficiency, innovation, and agility is the Industry 4.0. These are the key characteristics of smart industry. Being smart is needed for every industry today. Micro, small, medium, irrespective of size, we need to be smart. And it is not monopoly of large industry. The reason, as I said, the costings which were there in olden days, today those costings are much lesser. Let's begin the journey to the Industry 4.0. Revolution has to come from determined people. Machines can only help. If the entire organization is not ready for Industry 4.0, no matter how advancement you do, it is going to be of no use as such. Hence, the journey begins at preparing organization for the 4.0, having clear milestones and achievables well defined. We should know what we want to achieve out of the first initiative what we take. One of the things we should do is implement it step by step. Especially the small and medium industry, we cannot be taking up the entire factory to be taken up, because then we won't know what is going wrong, what are the, our manpower is not ready for it. So doing it step by step, going by either a machine by machine or a line by line, depending upon the size of your setup. Every step will be every step there will be difficulties and hurdles. Crossing them will help, crossing them with the help from experts. Now, every step you cross, every step, every difficulty you cross gives you the knowledge and gives you the wiseness. And that is what is more important. Then the extracting data from the present machine, visualizing this data and establishing reliability of it. When you go step by step, this becomes much easier. And once you have gone through most of the difficulties, it is easy for you to implement on a large scale. Scaling up becomes easy once you have faced. If your first implementation, you don't face any trouble, that means there is something wrong. You will not learn out of your mistakes. You should learn. Of course, you need not be doing a lot of mistakes, but those are what normally which can happen. And then analyzing this data on the edge. I'm talking about the small applications. I'm not talking about the big applications as such. I'm saying that the data need not be going to the cloud as of today, but the reliability of the data, what is coming, needs to be established. Simplest way is that you have the OEM and PLC partners, machine manufacturers and PLC partners. Then you have the gateways, edge gateways, those partners, and then you have software partners. Everything need not be done in-house. You have to take help from certain system integrators. There are companies like one of my biggest customer is TVS Motor Company. They have been doing it on their own. Most of the things are they have everything internally available. But there are companies like Hindustan Unilever, or there are companies like even small companies. I am not able to get the names, but small companies also, they take help from the external people, because they will not have the data analytics person with them. They would not have a PLC expert with them. So instead of that, they would take the help from outside. This is what about how to start, how difficult it is. It is as difficult as coming to the Chennai Trade Center and reaching this hall. You may have to ask for one person or two persons on the way, and then you are there. Tomorrow, if there is another seminar here, and if I have to come here, I don't have to ask anybody. So, Industry 4.0 and applying Industry 4.0 is as simple as that. You need experts, you need help from experts, no doubt about it, and that is available today. These are the applications what have been done. The simplest application, this application, probably you might find a date on this. This was done about 6 years ago. This was done for Addison. Simple data collection from the machine, production data. They wanted to collect the data and send it in the evening, at the end of the day, they wanted to send it to their ERP. So we connected it one of the edge routers, and the data was collected from different machines. I'm sure the cost of such project, There were 12 machines which were connected to that, and the data was being sent about the production part-wise, operator-wise. Of course, the analytics is the skill of software people. That was done, and the cost could be for a line maybe about ₹1,00,000, not more than that. Today, I'm sure 5 years back, maybe ₹1,00,000 was bigger. Today, when the markets are opening and there is a business opportunity and you want to have a reliability, I think this cost is not very high. It can come further down, but I don't think the cheaper or cheapest is not the solution in Industry 4.0. Smartest is the Industry 4.0 solution. These are the applications, these are the production monitors. What can be these production monitors? They can be connected in a industrial IoT. They can be connected to a smart TV, and that can show you. These are the good feedbacks to the operators saying that what they are doing, how efficient they are today. They are good. They should be better than they are, or they are better today. They should be best than that. And this is what the requirement. I mean, this was a requirement of one of the customers. Some examples of how the grinding machine data can be taken, how you can see whether the machine is on or off, what is the OEE of the machine. All those things can be done. These are on the die casting machine. I'm showing different slides because these are actually done applications into the field as such. For injection molding machines, these are, I'm trying to cover entire industry as such. This was done for probably a bigger company. This is monitoring the oven, roasting oven for a food industry. And here you have the data, everything available on the screen. Now this data is locally available. Locally people can be watching it. Multiple people can be watching this data. As well, this data can be available on the internet. This data can be available on a smartphone. So the maintenance manager might get an alert saying that, oh, that machine is down. And that is down for more than 30 minutes. Now there is going to be an issue. He can go online and he can check up what's happening. The same data, this is this is another data. This is for Hindustan Unilever. Here the data is presented in the format of the table, which is simpler to understand. For expert, he will be able to, people can concentrate on the red areas and not the green areas. You can see what is problematic, and then you can take the corrective action. This was a requirement of a pharmaceutical company. They wanted to monitor the temperature throughout for their clean room, for their chilling facility. And that temperature varies between -18 to 23. That was a limit which was given. So the entire day chart, they used to have somebody every now and then recording it, monitoring it. They used to have those chart recorders. Chart recorders used to fail. The paper used to get stuck. All those things. Now today they get this data. This data gets transferred as a PDF file, which is not modifiable. Of course, there are ways somebody can say, no, I can modify it. That's different. But it's not normally not modifiable. Every day, night, this is a 24 hours data. Every night it gets posted. It gets posted to people, those who are concerned about it. In between, if there comes an alarm, if there is a problem, if the temperature rises up or something of that kind, immediately the email is raised or a SMS is raised. That's what is the IoT is useful about. Then monitoring the quality, continuously quality monitoring. This was done for a hose manufacturing company. For the ID and OD monitoring, they have devices where they talk different language. One of the difficulty what will come across while implementing the Industry 4.0 is that different equipments, different PLCs, different controllers will talk different language. For example, Siemens will talk German. I mean, Profibus, Profinet. Telemechanic would talk French. I mean, Modbus or that kind of. So every company would have their own data protocol, and those protocols, they need to be brought onto one platform. Now, all the new machines probably hereafter might have OPC UA. This is a jargon, so let's not go into what OPC UA is. But OPC UA would become a standard as far as the control industry is concerned, is what being seen as of now. It might change, it might go to something else. But bringing onto one platform all the protocols is what one of the need is. Here the protocols are totally proprietary. There is a possibility we can write a protocol and collect the data. We did that, and that was what was done for, this was done for polyhose. For the hose testing, this is a full day production, including OEE of a line and all that. This is entirely for the full factory of Hindustan Unilever. Every night this data will get generated as a file and it will get posted. As well as it will be available for posting it into their ERP. Now this is all being done on a very, very simple way and not needing too much of a technology background for the people. Obviously, there is going to be a little bit shift required when we were using the normal keypad phones and then we started using smartphones. I don't think anybody has gone for smartphone using or smartphone users training. I don't think anybody has gone. We get a phone, we find it, we start playing with it, we learn it, and we understand it. And that's how the technology is progressing. Similarly, the Industry 4.0 related technologies are also coming to that level today. This is another example for fuel generator. High capacity fuel generators are generally not sold. They are on lease or rent. And then we need to know where the generator is, how much consumption from morning, and if there comes a problem, the service engineer should know before the owner of the generator comes to know that it is shut down. That is what industrial IoT or Industry 4.0 is going to do. This is a utility monitoring in the plant for, this was done for TVS, Hosur plant. You monitor because compressed air is one of the major utility. And yesterday, I mean, this would calculate even the cost per CFM or per day cost of the air used. Now coming simple thing, benchmark for good another thing people would like to monitor is the mean time between failure and mean time to attain, MTBF and MTTR. This is possible easily now with the help of data monitoring. We have talked about the data, we have talked about a lot of things. Where the data and why the data? Why so much of data? One of the biggest example, people have talked about the machine learning and artificial intelligence. What is artificial intelligence? What can be predicted or what intelligence we can be using when machine starts doing the intelligence is artificial intelligence. One of the classic example of artificial intelligence, I am sure everybody in this forum would be using it in day-to-day life. And that is our Google Maps. 7 years ago, first time when I used a Google Map in Bangalore, I landed up in a street which was too narrow for my car. Today that doesn't happen. Those days the Google Map would guide me, tell me the time required, and then it would keep changing. It would keep changing. Today, whatever I do, my time reaching, I travel a lot on the road. So if I'm going from here to Coimbatore, I'm being told that I would reach by so and so time. And I think everybody has this experience that you would reach within plus minus 5 or 10 minutes and not too much of out. If there is a blockade, of course, there are problems, but that's a different story. But in normal circumstances. So on a Sunday morning on my road, if there is no church, how much time I would take to travel on that? And if there is a church, how much time I would take to travel on that? Monday morning, school traffic. All this is a data which is gathered for over the years. You cannot do a prediction with one day's data. You will need a huge data. You will need a long data. So you cannot be predicting a maintenance or predicting a failure or non-failure of equipment overnight. You will need a data for 1 year. You will need the data from 100 machines. And then you will be able to do the prediction. The biggest question, this is about the investment. The investment, as I indicated to you, the investment can be as low as less than ₹1 lakh per machine or per line even. The cost, easy and cost-effective first IoT project can be done where you can get centralized overview of the whole fleet of machines, alarm displays, local dashboards for knowing what is happening. Data stays local as of now, but it can be taken to cloud also. This is the beginning of any journey of IIoT for a small or medium industry, and then expanding and scaling it up. Journey ahead is to take the process data to analytical and archival softwares for future use. One day data is not useful for any prediction. One needs to take the data for a long time and getting accurate predictions. Okay, this was taken. Now, what is the role of AI in all these? AI is automation. It's association of industrial automation companies. It's apex body for industry today. Pioneered vendor neutral approach for developing educational curriculum for universities. If a company is donating the equipments to that college, they may give a curriculum which is related to their product. Whereas AI has worked with many universities and given a curriculum which is not related to vendor. That means keeping out the economics, making sure that it remains educational forum as such. As what IIT has been doing or CMTI has been doing, similar thing. Promoting industry practices, skill consonants with global standards. About 2/3 of all industrial partners today, more than 2/3, are part of AIA today. What can be done? What kind of members we have? There is a list of it, but AIA as a apex body can be contacted and worked with. In fact, IIT Delhi has been working with AIA together. Sunil Jha. Yeah. So he has been working with that. Though he is a part of IIT, we from AIA have been working along with him to make sure that the upskilling done, all those things, whatever we have talked about, can be done. So we have a stall. AIA has a stall just about 2 lanes after this outside. Please do visit the stall and meet our people there. The best way is to stay connected. We are in the industrial networking as such. So we understand, we had been into PLC field from 89 onwards. We have been into the PLC field, and now we are into the IIoT. So we can be in touch. My email ID is there given. That's it. Thanks a lot. Thanks a lot for patient hearing. Thank you very much. Sure. No, I think there will be a common question session. No, one question I can take with permission. We'll take it in the common. Yeah, we'll take it in common. For some specific application, you will need specific data. Otherwise, a common data is good enough. No, sector-wise data cannot be correlated together. Because ultimately it's everybody's experience. So it is not yet collated together saying that what Madras fertilizer has done. No, that data won't come to me as such. In industry, that partitioning would remain. You would need to collect your own data if you are a fertilizer industry. And it is always better to have your own data. There are certain common predictions which can be there, but otherwise no. So, yeah.
Thank you, Mr. Deshpande. This is a bit offbeat. As of now, we have been discussing hardcore technology and development in technologies. But now, the aftermath of the technology, the application part, a lot of data is generated. So what you are going to do with this data? So this data is so important. You have to churn this data. You have to analyze this data. So here comes the function of big data, data analyst, and the data scientist. So how that can be utilized is a very good session which Mr. Deshpande has taken. And this has really given us a eye-opener for us, how to utilize this in the industry. Now we will be a bit shift from the normal schedule. See, since afternoon, we have been hearing deliberations from the status of Kishore Kumar, Muhammad Rafi, Manna Day, Sehgal Saab. Now we need to have Lata Tai with us. Okay. To break the monotony and make the session vibrant. No, everybody is in the sleeping mode, I believe. Please help me welcome Ms. Vinita Shah, who is the head of Global Strategic Alliance, 360 TF. I came to know from her, TF stands for Trade Finance. That means, no, whether you need it or not, she's going to force it on you. Is it so? If it is not, please hear from her. Please.
Thanks everyone for your patience through the session, and I love your analogy on Lata Tai. I don't know if I'll be able to match up to what she is or what she has done, but let's see how it goes. So to begin with, I would like to thank everyone for having me on the elite panel of industry stalwarts. Being a seasoned career banker, I must admit that this has been one of the most enlightening sessions I have had. Always speaking about finance and being in the finance industry, trying to see how we can match with what the industry wants. This was on the other side. I actually understood what goes into making what we are trying to help. So thanks for that. So I would try giving an insight from a trade financing perspective as we are trying to prep up for smart manufacturing and entering into the 4.0 that we are speaking about, how trade finance solutions can really be your support. I would make it very short and would like to make it a little interactive as well. So starting with the, at the beginning of the journey, financing the adoption of the new technology is what we can look at. Mr. Desai did mention in his initial discussion that a lot of SMEs, MSMEs are on the way of automation, and they are speaking about it. Some are at 2.0, some are at 3.0. And one of our panelists also mentioned that, you know, they are juggling between these things, and now we're talking about 4.0. Trade finance can help businesses keep up with this rapid pace of technology innovation that we are speaking about. Just to quote few numbers, the global smart manufacturing market is expected to grow at approximately $384 billion as we speak. This landmark number they plan to achieve by 2026. Of the recent survey that was conducted, 72% of the manufacturing executives have mentioned that the digital factories and achieving the digital factories in the next 5 years is what their agenda is. I have seen how a leading manufacturer have converted his entire processes into a digital transformation, which has helped them excel in their manufacturing output. And this is something which can be achieved through the trade finance solutions. The working capital help that can be extended would help them invest in these technologies that we are talking about, whether it's an AI or ML or IoT. This is how we can free space can be created for the funds so that it can be channelized on this side. Going to the next milestone in the journey, streamlining supply chain is again very critical. Smart manufacturing requires more streamlined supply chain management. the global supply chain finance market intends to reach to approximately $32 billion by 2026 again. And 60% of the surveyed companies have, it was a surprise to us, but 60% of the survey companies believe that improving supply chain visibility is on the top priority. So supply chain finance helps them in freeing up their capital, utilizing the funds where actually it is required from an automation perspective. So while companies can concentrate on their core activities, the supply chain finance is something which can be taken care by the financial institutions who are ready to support their hands. Going to the next one, while we expand the business and while we get into more geographies, what would be required is also to keep yourself safe from the transaction perspective. Mitigating the risk in the trade is equally important, and there are few very simple solutions available. One is trade finance insurance, which really helped all the manufacturers during the uncertain times. And the other would be trading the transactions with the help of letters of credit. While I would not really get into the technicalities of how it functions, would be happy to have one-on-one discussions on how we can utilize these solutions so that we can concentrate and move and be more prepared for our manufacturing 4.0. Another one that is again a critical point is enhancing global trade. So smart manufacturing, as we all speak about, is making it easier, the business that we deal into, and to expand the operations, expand the geographies. For instance, the Asia-Pacific region is expected to dominate the global trade at approximately 3.6% between 21 to 26. I believe that digital trade finance solutions that are now coming up, specifically looking at the requirements that we all have, while we're speaking about, again, the automation and increasing the manufacturing side, the finance side on the other side is equally prepping up with the automation so that we can match up with the speed with what the industry requires, and we can walk along with you guys. Another important topic that we all speak about is across the globe is the sustainable practices. Lot of organizations are now taking interest in the sustainable methods and processes that we speak about. Just to give the number again, the global market for sustainable finance intends to reach to around $2.5 trillion by 2025, which means the market is ready to finance the right kind of sustainable processes. Banks and financial institutions are looking out for funding these kind of deals that are there in the market. And I would say that 360TF, which institute I belong to, plays a very good matchmaking role in this, where we have the financial institutions who are ready to fund the sustainable processes. We also encourage our corporates to identify those processes which can be tagged on our system as a sustainable deal, which the financial institutions would ready to grapple on. So this is one of the very important advancement that we have done in our system, again walking in parallel to what's happening in the market and keeping up with the speed. We've very briefly touched upon a few points which are required from the perspective of how do we begin on all of this. As we move ahead, we've implemented it, we've seen this. Now we can talk about is improvising on the efficiency and the productivity, and which is what, again, the smart manufacturing is all about. We want to increase our productivity, but with the efficiency that we can bring in. Again, trade finance is something which is ready for this, and we are ready. All the financial institutions are ready to fund these kind of transactions and deals. just to conclude on this, I would like to say that, with all of you, while industry is grappling on and moving on with the different kind of automations that we may want to implement, I would say concentrate on that side of it. Concentrate on your core businesses and don't worry about your working capital cycles and your funding at all. We have experts taking care of that. Institutes like us and financial institutions are ready to work along with all of us. Let's walk hand in hand and make it achievable. Thanks.
Thank you, Vinita ma'am. It has been a bit offbeat, but very important topic for the industry because finance is very important and we need finance to start and do a business. Yeah, that is very important, one aspect. See, being the last speaker of any session is sometimes like in a session like this when you have a heavy download of information on your head, and then people get very sleepy and doesn't want to hear till the last speaker, and only it's very difficult for the last speaker to come stand here and really make the session interesting. But sometimes, people like Muthu Kumar, who is an expert T20 player, we have in him Virat Kohli. You'll have a very interesting session now.
Thank you, sir. Thank you for that nice introduction. So, very good afternoon to all. It's a great honor to be here to talk about the very important topic, Industry 4.0 or digitalization, what we call it. When we talk about digitalization, the question comes to our mind whether it's a pipe dream or a reality. If you ask me, I would say it's a reality, and we have been experiencing in our day-to-day life. So, one can vouch for it. The way we are, reading the books or going through the videos, or for that matter, transportation, in all aspects of, the walks of life, we have digitalization already inbuilt. So this evolution, taking it to the industry, definitely it is. It has also affected in a major way. So talking about the key challenges. So basically, need is the mother of any invention. That's what we have seen it. And digitalization is no exception. There are many challenges one industry is facing. So that, to overcome that challenges and to sustain the growth path, I think adoption of digitalization in any industry is very, very important and critical. So there are many challenges I have listed here. So industry is looking for flexibility in manufacturing, the speed with which they manufacture the product and the speed with which they want to market their product is, they're looking for, and the efficiency in the plant, in the production, and operational resilience. That is also is a very important KPI for the companies, and very importantly, the quality of the product while manufacturing it, and also the end product, the quality also matters, and all this with safe and secure plant. So that is also very important. So to address all this, I think digitalization is the holistic approach we will have it. So major the KPIs what we discussed is reducing the time to market, basically from the design level up to the production level, and also taking it to the market, and enhancing the flexibility. So now, the customer requirements are changing. The plant scalability, we want a different level of scalability and different, products in the same line. So every industry is looking for flexibility in their manufacturing areas, and definitely quality. See, the design, the manufacturing, and the quality all are interconnected. So this has to go in hand in hand, and they should have a very, cognizant system, so that your production efficiency improves and you get a quality product at the end. And definitely, I mean, last but not the least, the security of the plant or the machines or the complete system, that is also is taken care during the, I mean, when we adapt for digitalization. Okay. So, I mean, almost every one of us are there in the automation level, that is up to 3.0. There's a subtle difference between the automation and digitalization. Basically, all systems are connected independently, it is working. When you give a certain kind of analytical knowledge or the, what do you say, algorithms, it takes it to the next level of digitalization. So at machine level, at the I mean line production level, at the plant level, we can implement this. And so today what we have is highly automated system. Definitely with the small changes, we can take it to the autonomous system, which has a inbuilt, skill set or the logics, or it can take its own actions. The next course of action it can define and it can take it. So that makes the digitalization possible. To realize this, I think many of my, I mean, our previous speakers also spoken about this. From virtual world to the real world. See, if you want to produce any product, first we will put a rough hand sketch, right? So we will draw what is that we want to have it. And then we will work on it, we will improve on it, then we'll go for a production, then we'll bring a final product, right? So that we can have it in our software itself. So we can, I mean, we call it a digital twin. I think sir has also mentioned about a digital twin. So we will have a virtual world and we will work on it. We will define the performance parameters, the processes, and we can take that to the real world production. So the benefit is the end result. You can keep the end result in mind and you can work on the software, and straight away we can go for the manufacturing. You need not to spend money and time on the creating a prototype or checking the quality of the product or the process analysis. That is not required. Straight away you can work on the virtual world and that can be replicated to the real world. So we have a software called Digital Twin, which is serving this purpose. So we have a simulation software inbuilt. We call it Team Center, and we have NX MCD, the mechatronics software, and the complete process of from design to the end product is taken care in this software. So during the course of manufacturing, we identify the bottlenecks, the correction areas, the process optimization. All that can be taken care here, and and also again increasing the production time, the production efficiency that can be inbuilt. Yeah. So basically, I mean, in two different industries, I mean, discrete and process industries, we follow this processes. Like we have a product design, then then production engineering, then production execution, and even at service level, it is completely integrated, and we will have a very cohesive working, and the end product is very efficient, and I mean as per your expectations. So we are doing all this, but what is that we get at the end is what matters. So finally, we would like to, I like to highlight with some examples, live examples, and the use cases we have already done in the industry. I will not name the company, but this is for the FMCG industry. We have given this digitalization solutions, and because of which we are able to reduce or optimize on the space about a 30%, and about a 10% on the energy savings. So all these key KPIs we can achieve. And very importantly here, with this digitalization initiatives or the adoption, they could do or they follow their COVID protocols or processes very effectively. So it helps in such difficult situations as well. And one of the another example is this e-scooter manufacturing facility near Hosur. We have given complete the solution on digitalization, IT, OT integration, the cyber security solutions, because of which they are able to come out with the product within maybe 3 to 4 months time from boat to the road. That's what we call it in automotive language. So from boat to road, they could bring it within 3 to 4 months time. Next on the in-plant logistics and also warehouse management system, which is again a growing industry, and government of India is also spending a lot on this. I guess, extremely sorry. So here also we have in-plant logistics solutions. We call it AX4. We have given to one of the major steel plant where they have a warehouse management system or a truck monitoring system. All that is integrated, and it will help them to have a very effective in-plant logistics. And the another very good example is our own switchgear factory located near Kalwa, where I've listed the benefits before digitalization and after digitalization. If you go through this, we were having about 77 product variants manufactured in 3 lines before implementing digitalization. After digital transformation, if you see greater than 180 product variants manufactured in 1 line. So you can see the amount of the efficiency it has improved, and 21-second cycle time for 3 different lines, okay, for a single product, whereas now only 9-second cycle time for a variant product mix. 22 quality parameters check in 60 seconds earlier, and now it is 68 quality parameter checks in 9 seconds. So you can imagine the kind of quality checks we do during the process of manufacturing. And now this factory is acting as a global factory. The products manufactured in India is supplied all over the world. So it is meeting the which encourages companies to adopt advanced manufacturing technologies and process, including automation and digitalization. This has not only increased the competitiveness of Indian manufacturers, but also created new job opportunities. So here also we are contributing. And another very important initiative is the Skill India program, where we concentrate on training and upskilling of students or the budding engineers. So here, if you see from Siemens side, we have contributed for setting up a digitalization lab at ITI Chennai. So where we have helped them to establish a good digitalization lab where the new students or the ITS students can learn and understand about the digitalizations. Okay. So, and also towards Niti Aayog and Atal Innovation Missions, various initiatives have been taken by government, and all these initiatives, some or the other way, we are also contributing, and I'm proud to say that. So, with that, I would like to conclude my session. Thank you. Thank you for this opportunity. Yeah.
Thank you, sir. Before I ask our own Arunji to give vote of thanks, I will just want to take 5 minutes of you. I think I deserve that because I've been talking about everyone. So at least 5 minutes. Okay, this 5 minutes opportunity I'm taking to just elaborate on you about EPC's initiative in technology. So as of now, you have been knowing that EPC has got one vertical which is called trade promotion activity. Okay, when you get the finished product, now we are trying to promote it, to sell it in international market. But while doing so, what we have observed is that, okay, similar product, 4 or 5 companies going to different exhibitions, 3 companies are getting repeated orders, other 2 are not getting repeated orders. What is the issue? So the competitive advantage is missing. Where is the problem? So Ministry of Commerce has given us a mandate to identify and help MSMEs. So there might be quality issues, there might be commitment issues, there might be upgradation of technology issues. So as you know, MSMEs, sometimes they cannot afford to adopt latest technology, awareness is not there. They cannot afford to hire professionals because they are not knowing whom to take, or even if they know, they cannot able to take. So EPC has started about 4 to 5 years back an effort towards this. This is called Technology Center. We have got two technology centers, one in Kolkata, another in Bangalore. Okay. Kolkata Technology Center, how we do this, how we are helping MSMEs. Number one, we have a setup of 3D design and development center. We have got instruments like scanner, 3D scanner, which works on AI and ML. We have got a module, software module to convert 3D, 2D into 3D and design it into 3D and give it to MSMEs in a very affordable rate. We have got a 3D printer, so we can make a prototype, we can make a pattern and give it to them. So in the form of reverse engineering, we do a lot of things. So this is one aspect we are doing. The second is we are tied up with a lot of, many of the CSR labs, IITs, NIDs, National Institute of Waste Management, okay, Indian Institute of Welding, and through there we facilitate solving critical technical problems in the operations, in the quality aspects, in the maintenance, in the upgradation of technology, in the development of new product, wastage to product. So, for example, Eastern region have predominantly, as I told you in my previous deliberations, that it is a lot of casting industry is there. So casting slag comes out from the product, and which is a industrial hazard and an occupational hazard. So we have collaborated with Ampri Bhopal and come out with some productive product. So those products are like, they have built up tiles which can be used in the industry, which is 10 times, 15 times tougher than the ceramic tiles. We have tried to develop aluminum, this manhole cover, not from CI, which is logistically very heavy and involve a lot of cost. So aluminum and silicon composite material, we have developed manhole cover with the help of Humphrey. So these are some of the activities we are doing to help MSMEs. We are tied up with Pan-India NABL labs to give concessional facility to our members for testing facilities, for inspection facilities, pre-shipment inspection, calibrations. We are tied up Pan-India with certification bodies to give ISO certification and other certifications in very concessional rates. We are tied up with TERI. This is Engineering and Resource Institute. We are conducting free energy audit to industry, giving them a lot of scope to let them know how they can save and conserve energy. Okay, so lot of activity might be people might not be knowing that we have got another vertical and we're doing a lot of work. So we request all of you to go to our website, contact our regional offices across India, and let us know if you want any help, any technological help, any development, so we are there to help you out. Okay, so this is what I wanted to tell. Now I will request our own Arun Suklaji, who is our Northern Deputy Regional Chairman, to give us the vote of thanks. Arunji, please.
Good afternoon. This particular session of Automation Industry 4.0 was very relevant to my industry also. we manufacture equipments for the pharma industry. Pharma is a highly regulated industry. Mr. Deshpande has told, we need to integrate our lot of data with our equipments. So this such kind of initiatives, such kinds of sessions are very important from MSME perspective. Dr. Ramesh Babu, Chair Professor, B. Balarama Institute, IIT Madras, Dr. Amitesh Kumar, and Mr. Prakash Vinod, CMIT, Gokul Deshpande, founder of CMOS, Professor, Binita Shah, 360 TF, and Mr. Muthu Kumar, Siemens, and our immediate past chairman, Mr. Mahesh Desai. Distinguished guests, ladies and gentlemen and friends, it is indeed a great pleasure for me to present the vote of thanks for all the panelists and presenters participating in this roundtable session. I would like to especially mention the panelists and presenters from top-tier educational institutes and research organizations such as Dr. Ramesh Babu, the chair professor of V. Balarama Institute, IIT Madras, Dr. Mr. Prakash Vinod, the CMIIT, and making some time from their busy schedule to share their knowledge with us. I would also like to thank to Mr. Muthu Kumar of Siemens Limited and Mr. Gokul Deshpande of CMOS Professor for sharing their industry knowledge with us. A special thanks to NIAMT and EPC India has signed an MOU with NIAMT in the morning, and we hope that jointly we can do a lot of work for benefit of the industry. As we are all aware, automation and industry 4.0 is gradually becoming an integral part of global industry as it is instrumental in enhancing quality and productivity. In India, adoption remains a challenge due to a number of factors, chief among which is the lack of awareness among the MSMEs. Many a times, they have limited knowledge on the newest changes in automation and research institutions. Hence, events such as these are important to bring the industry and academia closer, thereby spreading greater awareness about the importance of Industry 4.0. Therefore, I thank EPC India for organizing this seminar as a part of IESS. I also again thanks all the panelists and taking their time for attending this seminar. Thank you.
Before we close the session, we'd like to, so no session is complete without recognition of the speakers. So we will do a little bit of small function of recognition of the speakers. I request my immediate past chairman, sir, Desai Saab, to volunteer himself to give some mementos to our speakers. Ramesh Babu, please. Huh? Yeah. You can tilt.
They want us to. So that UPC name can be seen.
Ha, ha, ha. Mr. Vinod, sir. Vinita, madam.
Finance. You have to respect finance.
May I request Arunji to come up? Dr. Amitesh Kumar, please. Mr. Deshpande, please. Mr. Muru Kumar, please. With the greetings from APC India, I declare this session closed. Thank you for coming, and we'll be want to see you tomorrow again at the same time. Thank you.
I am also exhausted.
A lot of guidance from you, so I'll call you up. Hope I can call you, or you can give me your number.
Mahesh Desai,
Just give me the number.
988 511 544